Hi there, this is Nate Moore, and I wanted to show everyone my Catapult activity. This Catapult activity is kind of a STEM lesson that I created earlier this year. How it works is, well, the idea is that we go over different parts of quadratics, and specifically we want to kind of encompass the parts about the time in the air that a shot is, the distance a shot can travel, the height of it, initial height, things like that, increasing, decreasing features of real life examples of quadratic functions. And I came up with part of this activity to try to give a real life example for my students to try to do. So essentially what the students do is I give them a spoon and about 7 sticks and about 3 rubber bands. And this is essentially what the original drawing looks like. What I ask them to do is try to fire some shots. Now, typically, I give them cotton balls and not anything heavier because I'm afraid they will shoot each other in the face. And I tell them very specifically, please do not shoot at each other or you will be suspended from this activity. Now, the content that this actually envelops is the the modeling section of Common Core standards in high school. Sorry. So typically what happens, directions, construct your catapult using directions given by your teacher, me, then answer the following questions. For part 1, you will fire and measure your catapult shot as it shoots from desk to desk. Once done, you will take the catapult to a station and then fire your catapult from desk to floor. So the point of that is that what I want them to do is shoot it from at a level height. That way they could figure out, hey, if my height is 0, well, how high does my shot go? How far does it go? So I give them some rulers, some measuring tape, and that's pretty much it. There's not a lot of materials other than the popsicle sticks, the plastic spoons, which tend to break, so I would get a couple more of those, rubber bands, which tend to break, popsicle sticks, the measuring tape, and meter sticks, so that way they can figure this out. Now, I do set up 2 stations for people to shoot for part 2. So what they do is first they fire from desk to desk. They ask the initial height, how far did it go? They can measure the shot, the maximum height of their shot, and how long the cotton ball was in the air. So that way they kind of can measure the height of it and the time. And the students actually really like this because then they can use their cell phones to kind of time them or slow down the shot so they can get a more accurate depiction of how high it actually went. So then when they go from shooting desk to floor, I set up a station so that way I have them go to a certain desk or about 2 different places, and I have the measuring tape on the wall so that way they can kind of see how high their initial height could be. And then I have one along the ground as well, so that way they can shoot it off the desk onto the ground in a specific direction away from people, so that way they can measure the shot, how it goes there. And then they calculate some of the same things: initial height, how far it shot, maximum height, and how long the cotton ball was in the air. Well, and then I want them to compare those two. Well, which one shot further? Was it the desk to desk or desk to floor? By how much? How far did it shoot? Or which one shot higher? By how much? And which one was in the air longer? So that's the first part where I want them to kind of experiment with it and see what the difference was. Part 2 is modification. I asked them to modify their catapult by either changing the cotton ball shot, adding additional sticks, more rubber bands, or changing the design in some other way. Be creative. I tell them they can go online and kind of search for various different kinds of models. Given that they're only given sticks and rubber bands and a spoon, some of the more elaborate ones they will not be able to do. This is also a partner activity, so it can be 2 people, 3 people, depending on the grouping. So I encourage them to kind of get creative with it. Some students will also modify their shots by putting more rubber bands on the cotton balls, making them essentially heavier. So then I asked them to explain, hey, what did you change or modify about your catapult? What do you expect to happen differently this time? So I asked them to make predictions about what might happen differently with their new modifications. So part 3 is keep firing and recording. So now with their new model, whether it's this model or one that you kind of made or copied, they're going to record the data going from, once again, desk to desk, then from desk to floor, and kind of comparing those shots as well. Afterwards, once they've recorded all that data, I want them to reflect on what they have shown or done. Which of the predictions that they made came true? Like, describe what happened. Did their model do better? Did it do worse? Did it shoot higher, farther? Was it in the air longer? Did any of their predictions not come true? Did they predict that, hey, this would have gone like across the whole classroom, or did it not? And then I asked them, well, what other modifications do you think you can affect how your catapult fires? Like, what other things can they do? Well, could they add more sticks? Could they make the sticks longer, et cetera, et cetera? They can ask about that. Then lastly, I asked them to talk to another group that performed a different modification. I don't want them to talk to the same kind of modification or people, other groups that have done the same modifications. I want them to ask another group that did something different. And I want them to record, hey, how far their modification went, how high it was, and how the time in the air. And ask them, what did they do differently? And was it more effective than your modifications? And if it was, why or why not? This way they can kind of compare. Now, what makes this really about STEM is this idea that they're using kind of engineering and math and science in some ways to try to make predictions and make their shot go as far as possible using limited resources. Now, it's all about experimentation. It's about reflecting on your experimentation and even conversing with your other students to try to determine which kind of worked best, which kind of didn't. And it's all about that kind of, experimentation process about this. So I think this is a really fun activity. It's very cheap. It's very fun. The kids get involved with it, especially if they can kind of record what they're doing. It's about a 1 to 2 day activity, depending on how your students are, how quickly they move. Sometimes they'll take forever just kind of building things or just shooting things around. They definitely will spend a lot of time just kind of firing shots just because they think it's fun. So they gets very, very involved, and I think they really like it, and I'd love to run this again.